In this video, we're going to discuss how to define a through-hole pad using Allegro and OrCAD PCB Padstack editor. As you can see on the screen, we'll discuss how to put all the diameters as per IPC standard 2222 and how to do their naming as per IPC standard 7251. This is section 1 and here I'll introduce GUI and different options supported by Padstack for through-hole pad definition. We'll start with selecting a through pin and a circular geometry. During our last discussion, we have skipped 3 tabs which are secondary drill, drill symbol and drill offset. So we'll start with discussing these tabs first. Let's click over secondary drill tab. On secondary drill tab, we'll see 2 options. One is back drill and another one is counter bore and countersink. First, we'll understand what is back drill. So while working over multi-layer PCB or multi-layer board, we use through-hole vias to transition between several layers. Sometimes these through-hole vias act as a stub for top or bottom to internal layers transition. To remove that extra part of via, we use back drilling. So I guess from this image, it is totally understandable. So as you can see, we have removed some part of the via by back drilling and the signal path is from top layer to internal layer. Let's go back to Padstack editor. So if I'll enable back drill, here you can see you can put the diameter of the back drill and symbol which will represent your back drill when you will import a NC drill legend file. Let's move to another option which is counter bore and countersink. So this feature you can use to create through-hole pad for a specific component which has some mounting part or shape or area which can sit inside the PCB. So using this drop-down menu, you can switch between counter bore and countersink. And from this image, we can able to understand what it looks like on our PCB board. Now let's move to drill symbol tab. Drill symbol tab is used to get information for each type of through-hole padstack which will reflect on NC drill data. So here you can put drill type, a specific character to represent this type of through-hole pad and drill figure dimensions. Let's move to drill offset tab. So using this tab, you can offset the drill from the center of the pad to a specific XY coordinate. Although we have already discussed design layers, but if you'll compare this tab to SMD Padstack design layer tab, you'll find few new layers names are enabled. So you'll get better idea about these extra layers when we'll demonstrate through-hole pad. So let's move to a demo of through-hole Padstack for OPAMP LM741 which has 8-pin CD package. We will going to create a through-hole pad for this 8-pin DIP package. I've already noted down the pin diameter and what should be the pad size as per IPC standard. So let's open Padstack editor and we'll begin with start tab. So here we'll select through pin and a circular geometry. Now let's move to drill tab. Here I've already selected circle. And in this tab, we have to enter the diameter value. So as per IPC standard 2222 level A, the formula we use to calculate the finished diameter is lead dia plus 0.25 mm. So in our case, lead dia is 0.46 mm and when we'll add 0.25, it will be 0.71 mm. So make sure you are using the correct unit here. So I'm just going to change it to millimeter. Now put the value of drill size 0.71 mm. That's it. Now the next step is we have to enter drill symbol information. So for that we'll move to drill symbol. Here we'll select circle. Character I generally use for different drills is either plus or triangle or X, or you can use some other alphabets. So here I'm going to use X and drill figure diameter. This should be same as the dia of drill size. So it will be 0.71. Now the next step is we'll move to design layers, because we are not going to put any offset from the origin of the pad. So let's move to design layer. Now inside design layer, if I select this first layer, begin one, so this is the information related to the pad size. So here we have to enter the pad diameter. So as per IPC standard 2222 level A, the formula for calculating the pad dia is hole size plus 0.7 mm. So in our case, hole size is 0.71. So that means the total pad dimension will be 1.41 mm. Alright. Now what we'll do, we'll just copy it and paste for internal layers as well as the bottom layer. Now for thermal pad and anti-pad, we'll again put the formula from IPC standard 2222. So for thermal pad and anti-pad, the formula is pad dia plus 0.3 mm. So that will be 1.71 mm. So if I'll select that, select circle and 1.71. Alright. Now I just wanted to copy this for these 6 places. So what I'll do, I'll just Control C, select all these together and Control V. So we can also copy and paste like that as well. So here we have filled all the information related to regular pad, thermal pad and anti-pad. Now let's move to our mask layers. For through hole, we use solder mask top and solder mask bottom. And as per IPC standard, the formula we use to calculate the solder mask information is 6 mil plus the pad size. So the pad size is 1.41 and 6 mil is nearly equal to 0.15. So it will be 1.562. Let's enter that information as well. 1.562. Alright, and it will be same as, so let's copy this, paste. It will be same for bottom layer as well. Now the next step is we have to save our pad stack. So we'll just click over this save button. And for naming convention, we'll use IPC Standard 7251. So let's locate the folder where we're going to save it. So it is on desktop. And for naming, so it is a circular pad. So it will start with C. Then next is we have to put the pad diameter, which will be 1.41. So it will be 141. Then hole size will be 0.71 mm. So 071 and click over save button. So that's it. We have created the pad stack. Now let's open PCB Editor 17.4. Click over File, New, select package symbol, and here we'll put the naming that we're going to use for dip as per IPC standard 7251. So the naming of the package will be DIP because it is a dip package. Then pitch 2.54, which will be 254. Length will be 0.46, which will be 046. Then thickness 7.37, so that means 337. Then height of the component will be 4.57, which will be 457. And the quantity of pins is Q8. So this will be the name of the component. Let's click OK. We'll use the default area. Now click over place pin, and from here we'll locate that. So the pin or the pad stack that we have created, it started with C, so we'll use C asterisk. This is the one which is C141H047. We'll click OK. And if I'll zoom in, you can see the pad stack is ready. So you can place, and by following the datasheet information, you can create the package. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.